3451 Introduction to Operating System. The topic is main memory, presented by Anuja or APCC, Rohini College of Engineering and Technology. The main memory is the fundamental storage unit in a computer system. It is associatively large and quick memory and save programs and information during computer operations. The technology that makes the main memory work is based on semiconductor integrated circuit. RAM is the main memory. The integrated circuit random access memory chips are applicable in two possible operating modes that are one is static and the one is dynamic. In static, it consists of internal flip-flops which store the binary information. In dynamic, it saves the binary data in structure of electronic changes that are used to capacitor. The capacitor are made available inside the chip by metal oxide semiconductor transistor. Random access memory is the memory of computer. Its objective is to store data and applications that are currently in use. The operating system controls the usage of this memory. It gives instruction like when the items are to be loaded into RAM, where they are to be located in RAM, and when they need to be removed from RAM. Then SRAM. SRAM consists of an array of flip-flop, one for each bit. SRAM consists of an array of large number of flip-flops are needed to provide a higher capacity memory. Because of this simpler flip-flop circuit, BJT and MOS transistors are used for SRAM. DRAM. It is also used for faster, but their cost is high because their cells require many transistors. RAMs can be obtained at a lower cost if simpler cells are used. A MOS storage cell based on capacitors can be used to replace the SRAM cells. Memory management. In memory management, program must be brought into memory and placed within a process for it to run. The input queue is a collection of processes on a disk that are waiting to be brought into memory to run their corresponding program. The address binding of instructions and data to memory address can happen in three different stages. One is compile time. If the memory location known a prior, absolute code can be generated. It must be recompiled code if starting location is changes. Load time must generate relocatable code if memory location is not known at compile time. An execution time binding delayed until runtime if the process can be removed during its execution from one memory segment to another. It needs hardware support for address maps. Swapping. A process can be swapped temporarily out of memory to a backing store and then brought back into memory for continued execution. The backing store, first disk large enough to accommodate copies of all memory image for all user, must provide direct access to these memory images. Roll in and roll out. Swapping variant used for priority based scheduling algorithm. The lower priority process is swapped out so higher priority process can be loaded and executed. The major part of swap time is transfer time. The total number of transfer time is directly proportional to the amount of memory swapped. The modified version of swap are found on memory many systems, that is Unix, Linux and Windows. So this is a diagrammatic representation of swapping. Thank you.